So now, just like with multiplication, we're going to deal with the division problems that you have to fix at the end. We could have done this at the same time with the multiplication problems. I've done that in the past, but it's usually a little too much for one class period, so you get two, I think, easier class periods out of this deal. All right, so let's make sure we know how to divide from yesterday. Right, so 6.2, you divide what would be the coefficients, but they're right there. 2 times 3 is 6, decimal straight up, and we get 3.1, and when we're dividing, we subtract the exponents. All right, oh, I actually wrote this as division just to show you that. So 9.5 divided by 5, 1, 4.5, 5 into decimal, not 4.5, 45, decimal straight up, 5 into 45, 9, so we get 1.9 times 10 to the negative second. All right, so number 3 is what we're doing today. We're doing 1.2 divided by 2. 2 doesn't go into 1, decimal straight up, 2 into 12, 6 times. Right, so we get 0.6, we still subtract the exponents, 5 minus 2 is 3. So we've done everything correctly, but what have we done wrong? Well, we haven't got scientific notation there. We have to fix it. So what would be correct? All right, I think you could guess, right? It's 6 times 10 to the what, though? Now we've made, if we go from here to here, we're making that bigger, right? 0.6 times 10 gets you 6. So we've multiplied it by 10. So we need to balance that out. So last time when we were doing the multiplication problems, we always added 1 to the exponent. Today we're going to be subtracting 1, right? Because the two answers have to be equal, right? 0.6 times 10 to the third is the same as 6 times 10 to the second, or 600. Right? So if you understand that, you already understand today's lesson. Right? So you'll divide. 1 divided by 4 is 0.25, and then you subtract 8 minus 5 for the exponent. Not scientific notation, so it's going to have to be fixed. So it's 2.5, but now you're making that bigger, right? 10 times bigger. So you have to make this 10 times smaller by subtracting 1 there, and that's the answer. Okay, so that's long notes saying what I just said. So let's fix this, right? That should be 5.3. We've made this bigger, so we have to make this one smaller, times 10 to the first. Right? We make this bigger, we get 6. We make that one smaller, 10 to the third. Those are equivalent, equal. Right? Now with small numbers, we make that 2, and we make that 1 smaller. So negative 4 minus 1 is negative 5. We move this once, we've made it bigger, 10 times bigger, once, 1.6, and then we make this 1 smaller, negative 3 minus 1, negative 4. Okay, so here's an actual problem from what we do in the homework. 1.2 divided by 4, right? 4 goes into 12, 3, so it's 0.3 times 10, 9 minus 2 is 7. That's not scientific notation. It needs to be 3. We move the decimal once to make it bigger, so we make that smaller. 3 times 10 to the 6 is equal to that. Same thing here, right? 4 divided by 5, it's top divided by bottom, is in fact, whoops, I gotta go too fast, is 0.8, and then we have 6 minus 9. Oh, let's write that out, right? Use top minus the bottom. So then it would be 0.8 times 10 to the negative third, but that has to be fixed, and it's 8, and we have to subtract 1 times 10 to the negative fourth. Right? You're making that bigger, then that makes smaller. When we were making this first number smaller, we had to make the exponent bigger. That's the pattern. It balances. So 2.8 divided by 4 is 0.7. All right, now we have negative 7 minus negative 5, right? Negative 7 minus negative 5 is the same as negative 7 plus 5, negative 2. But that's not a scientific notation. We need 7 times 10 to the negative third power, right? We're making that 1 smaller because we made that 10 times bigger. 3/4, if you know what 3/4 is as a decimal, just put it. 4 goes into 37 times. 4 goes into 25 times. 0.75 times 10 to the 0th is not scientific notation. So we have to put 7.5 times, we have to subtract 1, times 10 to the negative first power. 0 minus 1 is negative 1. All right, how many times larger problem is a division problem? Now we have to know the bigger one up top. Negative 3 is bigger than negative 5, right? On a number line, negative 3 is bigger than negative 5. All right, so 1.2 times 10 to the negative third divided by 3 times 10 to the negative fifth. 3 goes into 12 4 times, so it goes into 1.2 0.4 times. So we get 0.4 times 10, and now we have to do negative, I'm going to write it out, negative 3 minus negative 5, which is the same as negative 3 plus 5, right? So we get 0.4 times 10 to the second. Not scientific notation. Fix that. 4, and we got to subtract 1 times 10 to the first. So that's the answer in scientific notation, but it doesn't say to put it. You also could write 4 times 10. It's 40 times bigger. The smaller one times 40 equals the bigger one. It's 40 times bigger. A country collected 2.4 times 10 to the 12th dollars in taxes during the year. If there are 3 times 10 to the 8th people in the country, how many dollars is that per person? Now, this is roughly what we pay in America, United States, in income tax, roughly. So we're going to express our answer in both scientific notation and dollar form. So, right, we're having 2.4 times 10 to the 12th dollars, right, that we're paying, and there are 3 times 10 to the 8th people. So we're dollar per person is what we're going to get this in, right? Dollars per person from 7th grade. Dollars up top, people on the bottom. So we're doing 2.4 divided by 3. Decimal straight up, and we get 0.8 times 10. Division, we subtract the exponents and get 10 to the 4th. Now we're going to fix it. So we made that bigger, so we're going to make this smaller. And we put 10 cubed. And yeah, that's around, so 8 times 10 to the third. 10 to the third is 1,000. So 8 times 1,000 is, right, this is around $8,000. 1, 2, 3, 4. All right, and that is the answer. Okay, now that's roughly an average. The truth is, in America, the bottom 20% don't pay anything in income taxes, all right? But the top pay way more. That's just the average, which is sort of misleading. Okay, 3/5. 3 divided by 5. 3 goes to 36 times. So we get 0.6 times 10. 7 minus 2 is 5. Right? We know they're all going to need fixing today. We made that bigger, so that's smaller. And we get 6 times 10 to the 4th. 2.1 divided by 7. Decimal straight up. We get 0.3 times 10. And then we're doing negative 8 minus negative 3, which is the same as negative 8 plus 3, which is negative 5. We have to fix this, so it gets 3 times 10. Since we're making that one bigger, we're making that one smaller by 1. Negative 5 minus 1, negative 6. How many times larger? So the bigger number goes up top. We know that because 18 is bigger than 16. And then 3.6 divided by 6 is 0.6. 18 minus 16 is 2. Let's fix this. We made that bigger. We're going to make that one smaller. So that's correct. Or 6 times 10, 60 times bigger. So this is, remember, time equals the distance divided by the rate. So the distance here is 1.5 times 10 to the 11th. And the speed of light travels at meters per second. 3 times 10 to the 8th meters per second. 1.5 divided by 3 is 0.5. 11 minus 8 is 3. Move the decimal point and fix this. And so that's 5 times 10 to the second seconds, or 500 seconds. All right, because it doesn't say put it in scientific notation, so either way is good. Right? How many seconds does the light take to get here? 500 seconds.